So 41 student.
41 students are there only. You see 40 students are there.
Yes, sir.
These two are from the lateral entry. Uttama Pradesh, they are not responding. By the way. Okay. Let's start. Just proceed the previous topics and try to solve one or two more questions. Write down the questions. Question is solve. Simple. So AR, this equals to 5AR1 minus 6AR minus 2, and R minus 2, so R should be greater than equal to 2. So if you are taking R greater than equal to 2, that means here we have a A0 and here we have a A1. So this should be priorly known to us, and they are A0 and A1 both are same, and it is equal to 3. So this is your question. Solve it. So solve first. You take this, the characteristics equation. Characteristics equation is how much?
5R.
What is the highest? You see, what is the degree? Degree is R minus 2, that is the 2. Highest is AR. So this can be written as first this alpha square, this is alpha. Okay. So ultimately you can write it like this alpha square, and this is minus 5 alpha. Okay. Minus 5 and this is minus. So this side this becomes 6. This is equal to 0. Is it clear?
Yes.
It is of degree 2. So highest order is AR. Highest order is AR. So for AR you write alpha square and gradually you decrease this one. And it is 6 and 3. So minus 3 minus 2. This one. So it is how much? Alpha minus 3 and alpha minus 2, and that equals 0. So characteristics roots are 3 and 2.
3 and 2.
So what would be the required solution? Therefore, the
A1 R to the power 2
required
and
solution.
A1 to the power R.
Good. Next.
Plus A2 2 to the power
2
R.
to the power R.
Oh, good. So suppose this is 1. Now, since these initial conditions are given, so from that we can eliminate this A1 and A2. Okay. So what are the initial conditions? The initial conditions are given. The initial conditions are A0 3 and A1 is also 3. Okay. So now simply put it here. We have AR, put R is equal to 0. Put R is equal to 0. And next one is A1. R is equal to 1 for that. In 1. So what you will get? A0. A0 is equal to how much?
A1 plus A2.
So A0, one time you write A0 is equal to A1 into 3 to the power 0.
3 to the power 0.
And A2 2 to the power 0. And A0 is equal to how much? 3. So what you will get? So
A1 plus
A1 plus A2.
This is equal to 3. One equation. Okay. And suppose it is the another equations 2, and if you put a1 r is equal to 1, you will get thrice a1 and
3a1 plus 2a2
plus
equal to 3.
2a2 is
Okay.
equal to 3.
And this equals to how much? A1 is how much here? 3.
3, sir.
Okay. Now solve 2 and 3. Check it. Solve 2 and 3. How much you will get?
Sir, 6 and minus 3.
2,
Sir,
2,
I have a question.
minus, just a minute. 2, 2 minus 1. 2 and 3.
Sir, 6
A1.
and minus
A1, 6 and minus. A1 equal to how much? Minus 3, it's come.
minus 3, sir.
And A2 will come 6. And now, what is your question?
Sir, in the above question, it should be 1 is equal to 5 of alpha minus 6 alpha square, no?
Where it is?
The AR is equal to 5 AR minus 1 minus 6 AR.
In this stage.
Yes, sir.
I'm not getting what you are saying.
Sir,
At this stage.
meaning the roots.
Roots?
Yes, sir. Sir, it should be
The roots
alpha.
should be 1 and
Only one student said. What is the query? It is not clear to me.
Characteristic equation should be 1 is equal to 5 of alpha minus 6 alpha square.
No, sir. Sir, she is saying that the second line of this equation should be a square minus 6 alpha minus 6 plus 6. Sorry, sir. But in that case, you will not get the roots.
Okay, thank you.
Okay. By the way. So now, once you are getting this A1 and A2, so just simply put it here. So what is the solution? The required solutions of the, in fact, in this case, you are getting the particular solution because it is the homogeneous solution equation. So therefore, required solution is how much? Simply put it here, AR, this is equal to minus 3 into 3 to the power R plus 6 to the power R. Okay. Okay, or it is 3 to the power R plus 1, whatever may be. Now, once you are putting, so this is the another type of problems where we have to use the initial conditions to limit the arbitrary constants. Okay. So everybody solve one more questions, but do yourself this one. Okay. Next question is suppose solve AR, this is AR minus 1 plus AR minus 2, and R is greater than or equal to 2, and A0, A1, this is equal to 1. Solve it. Everybody solve this problem.
Sir,
Yes.
sir, in this case, I'm getting the roots as 1 plus minus root 5 by 2.
Yes.
Yes,
And sir,
mine.
a1 plus a2 is equal to 1, and
Yes.
a1 into 1 plus root 5 by 2 to the 2 plus a2 1 minus root 5 divided by 2 is equal to 1. These are the two equations. So
Now solving these two, you will get a1, a2.
yes, sir.
Solve these two.
So solving.
How much it is? AR is equal to how much?
So AR is equal to A1 into.
Just a minute, just a minute. You apply the initial condition also. Check this one. And R varies from 0. Okay, R varies from 0.
Sir, A1 I am getting 3 root 5 by 10 plus half plus minus.
3?
So
No,
minus
this should be.
3 root 5 by 10 plus 1 by 2.
No, this should be the alpha. You are getting alpha should be 1 plus minus root 5 by 2. This should be your alpha solution. What you are solving? Alpha square. This is alpha square. It is alpha minus 1, 0. Solve it. This is a well-known result. That's why I'm writing the result. This is the Fibonacci series. And this is the recurrence relation of the Fibonacci series. Sequence, in fact, not series.
Yes, sir, I am getting this same, sir.
Same, okay. So what is the value of A1? How much you are getting? How much you are getting? A1 is how much? This is your A1. These terms into
So
this.
minus root 5 by 10 plus half.
Minus root 5 by
10 plus half.
10. Oh, same thing you will get.
Yes.
After manipulation, you will get the same result.
Yes, sir, yes, sir. And A2 is
Okay.
minus 5 by 10 plus half.
Oh, that's okay. But ultimate result is this. This is the well-known result. This result is well-known result. It is a recurrence relations for the Fibonacci series.
Yes, yes.
So shall I solve this one, or everybody can solve this?
Sir, can you please solve this one? I am having some difficulty.
Okay. I will solve this. First come to the limit. Solution. First come to the characteristics equation. What is the characteristic equation? Alpha square. This will be minus alpha, and this is minus 1. This is equal to 0. Solve it. So alpha equal to minus b plus minus b square. It is 1, and plus 4. It is root 5 by 2a. So this is your alpha. So what should be the solution? Solution should be how much? AR is equal to A1 into one of them. Suppose 1 plus alpha root 5 by 2 to the power R. And the second one will be, you can take minus over here also, no problem. This into 1 minus root 5 upon R. So this is here general recurrence relations. Now we have the initial condition. This is our initial condition. So what we do here? Put A naught. in this equation, if you put 0, r is 0, r 0, this implies what? This is 1, and you will get 0, 0. So you will get a1 plus a2. This equals to 1. Okay, and r is equal to 1. This implies this is also 1. So you will get a1 1 plus root 5 upon 2. This is also equals to 1, or simply simply put the value of a2. What you will get? 1 minus a2, 1 minus a1. So you will get a1. Okay, and here instead of this a1, I am writing from here. It is 1 minus a1 from here. Okay, a2 is equal to 1 minus a1. So how much you will get? 1 plus root 5 upon 2, and due to this you will get minus 1 minus root 5 upon 2. This is a1. Remaining is 1, so it will go to this side upon 2. So how much you get? Minus, this is plus. So 2 times root 5 divided by 2, that gives you root 5, a1. And this side, this becomes 2 minus 1. It is 1, and this is plus root 5 by 2. So that a1 is equal to 1 by root 5 into this. Is it clear?
Yes, sir.
So if you are getting this, so therefore a2 equal to how much? a2 this equal to 1 minus root 5 upon 2. Okay, now solving this one, how much you will get? Root 5. So 1 by root 5, take the common. So this side becomes how much? 1 by, so this is root 5. This is root 5 minus 1 plus root 5 by 2. So how much you are getting? 2 root 5 and minus 1 minus root 5. So you are getting minus 1 and minus root 5. So let us write one more times. This is 2 root 5 minus 1. And so it is root 5 minus 1. Okay, or you may write it like 1 minus 1 by root 5, 1 minus root 5 by 2. Okay, so once you are getting this, so actually it is in this form. a1 is equal to this, and this is a2. Now put it here, over here. So how much you are getting? ar is equal to a1. Okay, so a1 is equal to simply put it this. So what you will get? Ar is equal to a1. Put it 1 by root 5 is common. Okay, to both this and this. This is 1 plus root 5 by 2 raised to the power r, and here 1. So we have a 1 plus root 5
by 2 r plus
r
1.
to the power r plus
okay
1.
by 2. Now plus, and this is minus. Okay, so put it minus over
Yes.
here, and again 1 by root 5, take common it, 1 minus root 5 by 2. So 1, and this is also, you see here, it is r over here. Okay, so r plus 1, and this is r plus 1. So this is your required recurrence relation. Is it clear?
Yes, sir.
Yes, so
What happened? Is it clear? So this is your solution this time.
Yes, sir.
Okay. This is your solution. So check this one. Okay. Now come to the next topic. I think it is clear how to find the homogeneous solution. Solution of the homogeneous linear differential linear recurrence relation. Okay. Now come to non-homogeneous. Okay. So solution of the non-homogeneous. Non-homogeneous, of course, non-homogeneous also included the homogeneous one. So topic is non-homogeneous homogeneous recurrence relation method to obtain particular solution. Is given by how much? Simply right hand side becomes FR. Is equal to FR. Okay. Suppose it is a 1. So how to find the particular solutions? Particular solution, that means the value of the AR such that the left hand side also becomes FR. This is a particular. So obviously this AR must depends upon, that means the solution must depends upon FR. Okay. So what you do, you may write like this: to obtain the particular solution, particular solution, that means when you are putting some values of AR, this left hand side also becomes FR. So obviously AR depends upon AR. So to obtain the particular solution, you may write like, so we consider a trial solution, you write it. We consider trial solution that depends upon or according to whatever the FR given, according to the form of FR. Okay. So depending upon the nature of FR, we will consider a different trial solution. Okay. So first case 1. Okay. So what is the case 1? If like in case of the linear differential equation, we have the form of fx on the right hand side is e to the power ax, or function of sine or cosine, or e to the power ax into some other functions gx, like this. Here also we have some particular type of FR from where we can easily get the solution. Otherwise, we have the method of generating function also. So if FR is equal to C, some constant, and if 1 sub is not the root of the, not our root, should not write the, 1 is not our root. Characteristic equation the particulars capital P. And what is the P? P is a constant. Okay. So if it is a, then particular solution is a constant. Okay. Case 2, 1 by 1, we will solve the problem also. Okay. Of degree K of T, suppose degree T. Okay, in R. So right hand side is a polynomial. So that is you may write it like how do you write it? FR. Degree of R in terms of T. So suppose this is F1 R to the power T R to the power T minus 1 like this, and we have a T roots, so we have a T over here, R plus F T plus 1. Suppose this is FR is in these forms, then what we will do, what should be the particular solution? Then particular solution is taken as the linear combination of the different powers of R. Actually, then particular solution is assumed to be it is constant. P1 is a constant, R to the power T. Okay. So simply instead of F1, F2, F3, we are applying some constant A1, A2, A3 or whatever may be, and using the initial conditions we should eliminate. No, directly we will write this one. So this plus P2 to the power T minus 1. That means instead of F1, F2, we should write P1, P2 and this. P plus P T plus 1. Okay, so this is your particular solution. That means AR is equal to this. You may write it here also. Is it? So if it is a constant, then directly solution is some constant. Now you need to eliminate this constant. If it is a polynomial, so instead of these constants, we should write other constants and rest of if FR is in the form of beta to the power R. Beta is the another constant, okay? Or depending upon the characteristic root, where beta is not a characteristic root.